All right. Thanks for joining, everyone. So this talk is kind of my overview of DevOps before and after the publication of this book called Accelerate. So if you heard about Accelerate when it came out in 2018, hopefully this rings familiar. If you haven't, I'll give you kind of a crash course in the main findings of Accelerate with a particular focus on what we've learned since Accelerate came out. I also give a story about how my understanding of DevOps has changed as I have developed in my career, and hopefully give you some takeaways about things to think about when you're trying to improve DevOps in your teams. As Tosin said, I'm a principal crafter at Eighthlight. Before that, I was an academic working in cognitive psychology, University of Wisconsin-Madison. For Eighthlight, I specialize in data science enablement projects, and my interest in DevOps in this talk is really kind of a long-held interest I've had in evidence-based methodologies for improving developer productivity. And the picture on the right there, I have a stonemason hobby. So if you ever get stuck in an elevator with me, you can expect me to be talking to you about stonework. So here is my history of DevOps. This is a select history. This is not an attempt to grab every meaningful event in the history of DevOps, but there's a few things I kind of want to draw your attention to in this chart. So first, thinking about where this kind of starts, DevOps definitely emerged from the Agile movement, specifically as it related to continuous integration and continuous delivery practices. And then when DevOps was really getting started, there was really this explosion of open source tools and public cloud services. So you can see when AWS came out with EC2, when GitHub started, Jenkins, Travis, and Circle CI all came out in the same year. Ansible came in there soon. And then in 2013, we had Puppet release the first State of DevOps report. So that was a survey and summary that they put out about the state of DevOps. And that kind of kicked off a whole research program for those researchers. And during the years of 2014 to 2018, that same group iterated and continued to put out that same survey. And then in 2018, they published this book, Accelerate, which was basically the summary of that 4-year period of running these State of DevOps surveys. And then what I want to focus on is what was the context in which Accelerate was published and what have we learned since? So there's some events, publications, and some thinking that's happened since Accelerate that I want to get to toward the end of the talk. So that history was not my history with DevOps. I wasn't really in tune with software at that time that I started learning about these DevOps concepts. I was a grad student at the time, and I had a very practical problem in that I needed to automate the process for getting code running on remote servers in graduate school. So one example of this is I had access to a computer lab for running experiments. So I had 12 different desktops in this computer lab, and I was running an experiment, and I really didn't want to be manually configuring each station. So without automation, I would have had to go to each station in between the sets of experiments we were running and run a bunch of commands and scripts and get the station back to what it needs to be at the start of an experiment. What I really wanted, and I didn't use these words at the time, was an idempotent deployment to a fleet of Snowflake servers. And if you've used the tool Ansible, you know that this is kind of what Ansible ends up being for. So I was exposed to the Ansible technology. I wrote some Ansible playbooks that automated the configuration of these lab stations for an experiment. And this had a dramatic impact on data collection for the lab because it meant I could go on vacation and I could have automation in place for the research assistants that were working with me so that they could do these steps even if I wasn't around. So what DevOps is to me, this is kind of one of the foundational experiences that kind of has formed how I think about DevOps. And it really is about deployments, and deployments being automated, fast, and frequent. I also use that word idempotent. A deployment should be something that's safe to run many times. This is kind of a core aspect of DevOps to me. Beyond just deployments, there's also an aspect of DevOps that's about infrastructure being managed and version control. And this is where we really are taking advantage of some of the changes that have happened related to open source tools and public cloud providers, such as AWS and Azure. So why I learned Terraform, this was really my love letter to the Terraform destroy command. So when I was first starting software, I was working on a web app for running psychology experiments online. And I really just had no idea what I was doing, and I was just breaking stuff all the time. And I really wanted to be able to break stuff safely and just trust that I could rebuild the entire environment from scratch. Then you get exposed to this wonderful marriage of Terraform and AWS, and I was able to write some Terraform code that could deploy my web application to n number of environments on AWS. That was kind of the dream, that I could tear down a dev environment and build it up again in a few minutes. and do it in a way that wasn't disrupting the other environments that we're running. So that's kind of the second sort of foundational formative memory for me about DevOps, is getting infrastructure as code and managing infrastructure and version control the same way we do our application code. And those two experiences probably do resonate with some people in the room, having to go from manual deployments where you're SSHing into a server to using some sort of tool that kind of automates that for you. If you use Terraform, you kind of know how powerful that can be when it comes to cloud-based infrastructure. This last one, though, is where I think my experience is a little bit different, which is about the proximity between development and deployment. So it's in the very name. DevOps is this, we kind of think about it as a combination of development and operations, really thinking about those two processes as being part of the same development cycle, that deployment should be a part of development. For me, since it was really just me, development was kind of close to deployment because there was no ops team. There wasn't anybody to hand over the application that I was trying to get run in for my experiments. I had to kind of figure out how to do that on my own. And so it was kind of natural that I would look to automate that process. Whereas I think many organizations, as they got familiar with DevOps, really it was about there being this distance between development and deployment, and specifically around, maybe the operations team being manual and slow. And so we end up with development being far away from deployment. But in both of these scenarios, it kind of leads us to the same conclusion, which is how do we speed up ops? How do we automate the deployment process? So this is the question that was kind of asked in the context in which Accelerate was published. Why speed up the ops team? Why should we, as technology organizations, dedicate time and resources to automating these operational tasks? What's the actual benefit we're going to get from trying to speed up deployments? So this is where this book comes in. Accelerate kind of formalized, it didn't introduce, but it formalized the DORA metrics. That's the DevOps Research Assessment metrics. And these are the 4 key measures of software delivery performance that they found through their survey. The first one, lead time for change. That's the time between when a commit is made and when that commit gets deployed into a production environment. The second one, deployment frequency. How frequently are you deploying the primary service or application that your team is working on? Change failure rate. What's the percentage of those deploys that have an issue with them? And mean time to recovery. When there is an issue, how long does it take your system to recover? So a key finding in Accelerate was that there were no trade-offs among these DORA metrics. Now, we can't just accept that on face value. I mean, if someone tells you that the lead time in their organization is at half an hour between when a commit is made and it gets into production, I'm going to probably make some assumptions about your change failure rate, about how frequently those commits are associated with issues. If you're really doing that, it might be just a lack of sort of quality control and code review that means someone can push their commit right into production. But Accelerate kind of debunked that. And they found that really these 4 metrics are really interesting because they go together. That if you look at organizations that are high performing, and high performing in this context has to deal with the success of the organization, its market share, profitability, they kind of were able to cluster the respondents by that performance. And you see that the high performing organizations were the fastest to deploy. They had the shortest lead times, and they also had the shortest mean time to recovery and the lowest change failure rate. So this was really kind of a key finding of Accelerate, is that we're not trading off. Going faster doesn't mean that quality is going to go down. We can do these things together, and that's faster is really fundamentally good in this context. That wasn't the only thing Accelerate is about, although that was certainly one of the key findings. The most interesting findings in Accelerate to me were really about the relationship between software delivery and other aspects of organizational culture. So one of their findings that sort of resonated with me and sort of made sense, but I think is really interesting, is that continuous delivery practices were related to quality of life improvements reported by the engineers. So if you are deploying more frequently in smaller batches, you tend to have less pain associated with those deployments. And that also means that your employees are less likely to get burned out. Their job isn't as stressful when deployments are not stressful. I think that's a really interesting finding. And this sort of finding introduced evidence-based reasons to adopt DevOps beyond just the organizational performance. And I'm going to get back to that a little bit later. So Accelerate comes out, they formalize this idea of the DORA metrics, these 4 magic numbers that every organization should care about and try to optimize. So now what? Now what do we do with all of this information? In the time since Accelerate, I just want to call out some common pitfalls that I've seen people fall into after reading Accelerate. We'll kind of take these one by one. So the first is, let's instrument all our CI/CD systems. It kind of makes sense. There's engineers looking at these metrics such as, lead time, and they naturally think about a way to automate that. All we've got to do is scrape our Git repos to find out when commits were made, and we can correlate those with logs from our CI/CD systems, and we can automate the collection of our delivery metrics by just adding this instrumentation. However, the point I want to make to you is that adding significant digits to these delivery metrics doesn't really have a meaningful impact on how your team prioritizes improving them. It doesn't really get you that big of a benefit compared to the survey-based method, which the Accelerate team kind of put together. So just to give a little bit more context on that, so here's a sample question from the State of DevOps survey, measuring deployment frequency. So the question asks, how often does your organization deploy code for the primary service or application you work on? And you select among these multiple choices: on demand, between once per hour and once per day, between once per day and once per week, once per week, once per month, once every 6 months, and beyond that. So an engineer will very much look at this and say, why, these bins are not equal sizes. The difference between 1 week and a month is not the same as the difference between a day and a week. So wouldn't it be great if we had kind of continuous measures and exact values for when we're doing this deployment? The truth is that isn't actually helpful from an organizational perspective, like how you're actually using this data to motivate improvements that you're making within your systems. So I'm going to propose a different way for you to think about the DORA metrics. They aren't necessarily these magical numbers that we should be able to try to measure in a programmatic or automated way. We can think about them kind of like a personality test for our DevOps team. Thinking about the start of when personality research started, psychologists would ask people hundreds of survey questions. Just imagine, and nobody likes taking a long survey. I mean, this was really brutal. Hundreds of questions about your personality. And over years of research, they grouped those as they related to what they identified as the big 5 personality traits. So I would bet that a lot of you have taken a personality test that rated you along these big 5. This was a really sort of a foundational framework for personality and psychology. Over years of research, they basically were able to distill that down into just 10 items. So now today you can take a 10-item personality test that essentially has similar validity to that long form test. So if I can ask you 10 questions and I get the same value out of it as asking 100, I'm going to just kind of stick with the short form as much as possible. That's the first pitfall is about, trying to get significant digits associated with those delivery metrics and the automated collection of them. Let's talk about the next one. Let's all start using Kubernetes. So Kubernetes here, I'm not trying to pick on Kubernetes, but this is basically anyone who reads Accelerate and decides that the problem is a lack of tooling, or really that there's any specific technology that is going to solve all their problems for them. This has been kind of true for DevOps from the start. DevOps has always tried to be not about the tools, even though, as I mentioned, the tools were certainly a part of the history of DevOps. Accelerate really doesn't recommend any specific tools, but they do discuss how tooling decisions are made. This leads to the finding from Accelerate that I love to cherry pick whenever I need to, which is that in Accelerate, they found that teams that were able to pick their own tools were really the ones that were driving software delivery performance. So rather than being prescriptive about your tools, really letting the teams pick their own tools, it was one of the takeaways from Accelerate. Now, I think that tooling decisions can be benefited by this Accelerate framework because we can think about them as hypotheses about how we're going to improve software delivery performance. If you think that Kubernetes is going to help your lead time and your change failure rate, well, state those as hypotheses, collect the data before, and see if it actually does. Start by rolling that out for an individual team and measure the impact there before you roll that out everywhere else. So that's the second pitfall about focusing on a particular tool. And this last one, let's spin up a DevOps team. This is the one that I've spent definitely the most time thinking about since Accelerate was published. I have a theory that Accelerate is the book that launched 1,000 platform teams because it felt like after this DevOps stuff, everyone was talking about these platform teams and DevOps teams. Many organizations have started teams to provide infrastructure and tooling to support software delivery. But we really have to prevent falling into the traps that we had before the DevOps movement of having these separate teams that are in the way of deployment for other teams. One sort of glib way to say this is don't let your DevOps team become the only team that knows AWS. You don't want them just to become another version of cloud operations or something like that. We need to kind of try to avoid those boundaries from slowing down software delivery. The beneficial way to think about platform teams is to really empower our teams to build internal products. It's really important. You can treat engineering teams as customers, approach it like you would any other product, think about the thinnest viable platform that you can stand up and deliver value to your customers internally. And we can measure performance against key software delivery metrics. Internal platform teams probably can't be measured against business KPIs in the same way that other teams might. So we need to kind of establish what are the KPIs for our internal platform teams. And I feel like Accelerate kind of gives us a good foundation, some starting points for understanding the benefits there. Talk a little bit more about platform teams. So after Accelerate came out, there was this book published called Team Topologies. And this was really kind of an aspect that Accelerate didn't talk about. It didn't talk about team composition as having a role in software delivery. But this book really argues that the team is the most effective unit of software delivery. And we should think about software architecture and team interactions being designed together. So this is really about how you structure your teams and how that maps to how the software your teams work on is structured. One interesting implication of this is that your organizational structure, you might not be aware that it's constraining the solution space explored by your teams, if that these teams feel like they can only solve the boundaries of the team as it exists today. Whereas if there were different structures of teams, they might approach the problem differently. I feel like that's a valuable takeaway. And this last one is interesting too, where you can actually use team topologies to limit communication paths. And that can actually be beneficial from a system architecture perspective. That might have the consequence of producing modular and decoupled systems by way of organizational structure. The Team Topologies book outlines these 4 team types and 3 different interaction modes. These are kind of the fundamentals of team topology. The primary team type is that stream-aligned team, and that's basically what we would think of as a product team, a value stream end-to-end that is deploying something that has users. And the other 3 teams are kind of versions of platform teams. The first one, an enabling team, might work across different stream-aligned teams, but it kind of meets the stream-aligned teams where they are, kind of works within their code base or produces tooling that they can pull in at their leisure, which is different than a platform team, where a platform team might have kind of a standalone service that's used by teams, where the teams have to integrate with the platform as opposed to the enabling team going to the team that needs the help. And then you have a complicated subsystem team. This is a strategy for basically pulling complexity out of a stream-aligned team into a dedicated part of the system. And then you have these different interaction modes. I think this is a really interesting theory of how to, should I say, weaponize Conway's Law, but this was not a book about data. So their Team Topologies is very much kind of describing these things, giving you some thoughts about things to try, but it really wasn't backed up by data in the same way that Accelerate was. So it remains to be seen if team structure really has a measurable impact on delivery metrics, but I'm certainly eager to kind of see the evolution of this framework. So what about moving beyond the DORA metrics? So the DORA metrics are really focused on software delivery, and there's a lot of teams that just can't measure the DORA metrics as they were maybe originally intended. They just kind of have a different cadence for production deploys, or maybe they're coupled to people downloading a new version of the app versus a web app, which you can push out new updates at any time. So there was some of the researchers behind Accelerate, they've really moved on to develop 2 additional frameworks. First one is the SPACE framework, and the one that came out earlier this year is called the DevX framework. These frameworks consider software delivery as one aspect of this broader umbrella of developer productivity, which I think is a helpful movement in this space. I will give you a brief overview of these different frameworks. So the first one, SPACE, the acronym here, satisfaction and well-being, that's certainly not measured in the DORA metrics, right? Lead time to deployment, change failure rate, those, we've kind of correlated them with some aspects of satisfaction and well-being, but this is kind of saying that should be one of the primary metrics that we really take into account when we're thinking about the performance of our teams. Performance and activity, those have aspects of that software delivery to them. How frequently are we getting things into production? How many steps does it take to get something into production? And what's the likelihood that when we get something into production that is successful, it doesn't fail? Communication and collaboration, efficiency and flow. The argument of this paper is that if you want to understand the productivity of your teams, you need to be sampling from multiple of these dimensions. So one of the recommendations they make is if your team is already using, let's say, number of pull requests as a developer productivity metric, that kind of is in the activity category. And so if you want a better understanding, you shouldn't just get more metrics that measure activity. You shouldn't look at other things that are kind of related to lines of code. You should try to come at it from a different angle, measure aspects of satisfaction and well-being, look at communication and collaboration. Other aspects is really what they're arguing for here. The next framework, this DevX framework, I think is kind of a simplified version of the SPACE framework. It kind of boils down to thinking about developer experience along these three dimensions: feedback loops, flow state, and cognitive load. DevX focuses on developers and their lived experience delivering software, sort of valuing the survey data in addition to the system data. So that includes performance of the engineering systems as well as the perceptions of the developers using those systems. So this is just expanding the DevX framework a little bit more. You can see the different themes as the columns there. And then we kind of have two rows associated with perceptions. What are the developers sort of self-reporting about their subjective feelings when they're doing their work? And workflows. These things kind of have maybe true numbers to them. So we can see that in addition to just looking at deployment lead time, we should also be taking into account whether or not developers working in that system are satisfied with how long it took. Maybe development lead time looks okay, but the developers are unhappy with it. They think it should be faster. Or maybe development lead time looks slow, but it actually isn't blocking your developers because by the time they get around to starting a deployment, they've already done most of the work and it's okay for it to take a little bit longer. So this is just kind of adding some dimensionality to how we measure developer productivity and ultimately identify ways of improving it. And then we can tie all of these back to kind of some self-identified KPIs that an engineering experience team might focus on: overall perceived ease, employee engagement or satisfaction, perceived productivity. We kind of hope that some of these smaller improvements to feedback loops, cognitive load, and flow state would trickle up to some of these larger KPIs that could be measured. Let's return to the question at hand. What is the state of DevOps? We had this question about why should we speed up the ops team? And I think the answer after Accelerate was kind of crude, but it just basically said because deploying more frequently is good. But I think with what we've learned since Accelerate, we can add some nuance to that. And we might be able to talk about how the ops team's deployment process has a high cognitive load and it's got slow feedback with the teams involved. And it results in teams being taken out of flow state during their development and deployment activities. And that seems like a much more nuanced problem to tackle in different ways. But I really like that those sort of terms, the cognitive load and feedback loops and flow state, are the way to talk about improvements to operations, as opposed to just thinking about faster being better. So now we can kind of use what we've learned there and apply it to the new kid on the block, MLOps. So what's the state of MLOps? MLOps emerged from DevOps, at least that's what a lot of the MLOps literature says, as a way of trying to fit continuous integration and continuous delivery to the lifecycle of ML models. I could have done a similar sort of chart of the history of MLOps, maybe someday I will, but I do want to call out that it was similarly transformed by a bunch of managed ML services and open source tools that have been released. Amazon SageMaker is a good example. When TensorFlow came out with its TensorFlow serving, that was really kind of thinking about the production environment first in a way that some of these machine learning frameworks were a little bit late to come around to. Hugging Face, public repository for a bunch of pre-trained models, really transformative. And then more recently, we've got technologies like Pinecone, vector databases, and how to make very performant machine learning models in production. One of the recent technologies that I'm really interested in is feature stores. Feast is one of these tools that's used for online inferencing and offline model training. So again, we're kind of being overwhelmed by a bunch of different tools, but I don't really feel like we're learning the lessons of DevOps. I feel like MLOps today looks a lot more like ops for ML models than DevOps for data scientists. We need to be thinking more about not just having a team that's doing these operational duties with whatever tools they have available, but kind of thinking more comprehensively about the teams that are producing those models, being in close proximity to them as they get into production. So we can take some of the learnings from this talk and apply it to MLOps. If you were charged with starting your MLOps team, how would you do it? Well, I would recommend that we apply a platform mindset, and we can use the DevX framework to solving this problem. So we should think carefully about how we are structuring our teams as we are delivering ML products. Where are the team boundaries, and what does that mean about the architecture of the system? And can we change the team structure and have an impact on how those systems are architected? I would say that we don't yet really have the equivalent of the DORA metrics for ML. I mean, if you think about the traditional change failure rate, probably doesn't really apply for a lot of ML models, that they are successful, they like pass the smoke test and they return a response, but the quality of the recommendations or predictions is dropping dramatically. That isn't really captured in the change failure rate. So there's probably some work we need to do to figure out what the right metrics are for when it comes to machine learning delivery. And applying that DevX framework, I think we should be thinking about how to prioritize efforts to speed up feedback loops and reduce the cognitive load of ML deployments. And those are the problems we should be tackling when it comes to MLOps. All right, so I'm going to go through a few takeaways here at the end, and then I will take any questions. So the first takeaway I hope you have is a deeper understanding of the DORA metrics. Accelerate, I tried to position Accelerate in this historical context. It was really published during this explosion of DevOps tools and services. And they identify these 4 key metrics that they found to be predictive of organizational performance. And they argued that there are no trade-offs among these DORA metrics. That was one of the key findings from the Accelerate and State of DevOps body of work, that you can move faster and be safer, and those things are related. The second takeaway I hope you have is that a simple survey is a pretty pragmatic approach to measuring software delivery. It's not necessarily worth it adding significant digits to your delivery metrics. They probably aren't going to have a meaningful impact on how your team prioritizes improving them. I would encourage you to think about the DORA metrics as kind of a quick 4-item personality test for your software development teams, something that's easy to do on some regular cadence, and it gives you some benchmark data and some areas to improve. The last takeaway here is that software delivery, what we've learned since Accelerate is that software delivery is just one aspect of developer experience overall. The space and DevX frameworks are expanding upon the DORA metrics, still kind of early in the research refinement phase, but they're probably going to be more useful for a wider variety of teams that don't have maybe a traditional web app deployment cadence to measure against. And I hope that you start talking in your teams about cognitive load and feedback loops and flow state when it comes to improving developer experience. We don't need to be saying that one tool is just better than the other. We should be talking about those tools in the context of these dimensions of developer experience.